हेलो स्टूडेंट, दिस इज अर्चना गांगड़। स्वागत है आप सबका मेरे इस चैनल पे। आज का हमारा टॉपिक है एप्लीकेशन ऑफ मैट्रिसेस। अंडर एप्लीकेशन ऑफ मैट्रिसेस इन द प्रीवियस वीडियो वी लर्न अबाउट द इन्वर्जन मेथड. In this video we are going to discuss about the method of reduction. Now what is exactly the method of reduction? Here we have to solve the system of linear equation which is given to us and to find out the values of x, y and z. So what are the steps to solve the system of linear equation? So let's see. This is your system of linear equation which is given to us a1x plus b1y plus c1z equal to d1. Second equation a2x plus b2y plus c2z equal to d2, and third equation is a3x plus b3y plus c3z equal to d3. The first step to solve this equation is first we have to convert the given system into the matrix equation. Now what is exactly the matrix equation? In previous video also, when we solve the inversion method, we have to first convert the given system into the matrix equation. Same step here. The matrix equation is Ax is equal to B. Now what is A, X and B? We know A is a coefficient matrix, X is a variable matrix and B is a constant matrix. So how to convert the system into the coefficient matrix? The coefficient of X variable, that is a1, a2 and a3. Coefficient of x variable a1, a2, a3, it should be in the first column. In second column, the coefficient of y variable, the coefficient of y variable is b1, b2, b3 here. And in the third column, we have to write the coefficient of z variable, that is c1, c2 and c3. X is a variable matrix, so write x, y, z, which is variable given to us, equal to the right hand side. What we have to write in right hand side? The constant value of a equation, that is d1, d2 and d3. So this is the first step, how the given linear equations convert into the matrix equation. Now second step, we have to perform the suitable row transformation on the matrix A. To reduce it an upper triangular matrix और a lower triangular matrix और a diagonal matrix. इन तीनों में से किसी एक को हमें मैट्रिक्स A को रिड्यूस करना है. Either you have to convert it to upper triangular matrix या तो फिर आप उसको lower triangular matrix में convert कर सकते हो. Otherwise you can convert it into the diagonal matrix also. तीनों एग्जाम्पल हम देखेंगे अभी. The same row transformation should be performed simultaneously on a right hand side matrix, and the right hand side matrix is a B matrix. This is our second step. Now the third step is, after solving it, rewrite the equation in the form of system of linear equation and solve it by elimination. We get the required solution. It means we get the values of x, y and z here. I hope you understand what are the steps to solve the system of linear equation. Three steps are there. Now here what is exactly the upper triangular matrix? In previous slide, second step, what we see, the matrix A should be reduced to an upper triangular matrix, lower triangular matrix or a diagonal matrix. So what is exactly the upper triangular matrix? The upper triangular matrix has all the elements 0 below the main diagonal. Now see the example here, 2 by 2 matrix is given, 2 rows and 2 columns. So this is your diagonal element 2, 5. That is called the main diagonal of a matrix. Below this main diagonal, all the elements are 0. So this is a upper triangular matrix. In a 3 by 3 order, 1, 2, 5, this is your main diagonal. Below this main diagonal, all the elements are 0. So it becomes a upper triangular matrix. So this is the example for upper triangular. Now what is exactly a lower triangular matrix? Exactly opposite to the upper triangular matrix, the matrix which has the element 0 above the main diagonal. Diagonal के ऊपर के सारे numbers 0 हो जाएंगे. That is called the lower triangular matrix. Example is again 3, 1 is a diagonal, main diagonal. Above this diagonal all elements are 0. यहाँ पे भी second matrix में main diagonal is 3, 2, 9. Above this diagonal, all elements are 0. So this is a lower triangular matrix. Now next is a diagonal matrix. Now what is exactly a diagonal matrix? The diagonal matrix is a matrix in which the entries outside the main diagonal are all 0. तो तो यहाँ पे देखिए एग्जाम्पल, डायगोनल वैल्यूज आर 4 1, ये डायगोनल वैल्यूज छोड़ के जितने भी वैल्यूज वहाँ पे मैट्रिक्स में होंगे ऑल वैल्यू शुड बी 0, सो दोनों जगह पे 0 है, सो दिस इज ए डायगोनल मैट्रिक्स। सेकेंड एग्जाम्पल में भी 2 1 4, these are your diagonal matrix और diagonal element, 2 1 4 is a diagonal element, उसके नीचे और ऊपर दोनों जगह पे सारे एलिमेंट्स 0 है, सो इट इज ए डायगोनल मैट्रिक्स। सो कोएफिशिएंट मैट्रिक्स को हमें आइदर डायगोनल मैट्रिक्स में कन्वर्ट करना है, लोअर ट्रायंगुलर में करना है या फिर अपर ट्रायंगुलर में करना है। अभी आपको समझ में आया कि वो डायगोनल मैट्रिक्स, अपर ट्रायंगुलर मैट्रिक्स एंड लोअर ट्रायंगुलर मैट्रिक्स होता क्या है। Now let's take the example. Solve the equations 2x plus 3y equal to 9, y minus x is equal to minus 2 by using the reduction method. अभी हमें तीनों स्टेप्स फॉलो करने हैं। फर्स्ट, जो कोई भी सिस्टम दी है, कन्वर्ट दैट सिस्टम इनटू द मैट्रिक्स इक्वेशन फर्स्ट। सो राइट दैट इक्वेशन और द गिवन सिस्टम ऑफ इक्वेशन एज इट इज by matrix equation. What is our matrix equation? Ax is equal to b. Now A is a coefficient matrix, as we know, X is a variable matrix and B is a constant matrix. So let's write for coefficient matrix in a first column. What we write here? The coefficient of X variable. What are the coefficient of X variable here? X variable is 2. In second equation it is minus 1. So in the first column the entries are 2 and minus 1. Now in the second column, what are the coefficient of y variable? So observe the first equation, coefficient of y is 3. In second equation, coefficient of y is 1. So it is in the second column, the entries are 3, 1. X is a variable matrix, only two variables are given to us, x and y. So write only x, y. Equal to right hand side constant values are 9 and minus 2. So B matrix is 9, minus 2. Now second step, we have to reduce the coefficient matrix A to the upper triangular matrix by using suitable row elementary transformation. So this is your diagonal element 2 1. Below this diagonal, that means this position 8 to 1, you have to make 0. Now it occurs in the second row. So second row will be changed. How it will be changed now? We have to multiply the second row by 2. 2 into 1, it becomes 2 into minus 1, it becomes minus 2, plus first diagonal element, that is a11 with respect to that element is 2, so plus r1. So second row will be changed, 2 times r2 plus r1. First row will be as it is, no change at all. So apply the second row elementary transformation, 2 into minus 1, it becomes minus 2, plus r1 value is 2. So minus 2 plus 2, it becomes 0. The same corresponding element next, 2 into 1 plus r1 value is 3. So 2 into 1 plus 3, it becomes 5. Second variable matrix as it is, right hand side value same constant matrix पे भी हमें same row operation perform करना है. So 2 into minus 2 plus r1 value is 9. So 2 into minus 2 minus 4 plus 9, it become 5. So this is our next step. Now observe this matrix carefully. This is your diagonal element 2 5. Below the diagonal, all the elements are 0, only one element is there, so that element is 0, so it becomes a upper triangular matrix. Now we can convert this matrix in a equation again. So write 2 into x plus 3 into y equal to 9. Next 0 into x, so no need to write here 0 into x, just write plus 5 into y. 5 into y is equal to right hand side constant value 5. So we get this two equation number 1 and equation number 2. Solve the equation 2, y is equal to 1. After simplification, substitute this value y equal to 1 in equation number 1. So what we get? 2x plus 3 into 1 is equal to 9. So after simplification of this equation, we get x is equal to 3. So that is our required solution, x is equal to 3 and y is equal to 1. I hope you understand this first problem. It is very easy, just we have to reduce the coefficient matrix to upper triangular matrix. अभी हम second example देखते हैं जो कि diagonal matrix को coefficient matrix convert किया है. Now solve the system of equation by the method of reduction. In previous example, students, we we find only two variables value. Here three variables are given to us, x, y and z. जो कोई भी system हमें दी है, first write that system into the matrix equation. This is our system, first equation, second equation and third equation. Write that equation into the matrix equations. So this is our matrix equation, Ax is equal to b. Now in the first column, we write the coefficient of x variable. So observe the equations carefully. Coefficient of x variable in the first equation is 1. Coefficient of x in second equation is also 1. And in the third equation it is 1. So in the first column, 1, 1, 1 entry should be there. In second column, we have to write the coefficient of y variable, and that coefficient is 3, 4 and 3. In third column, we have to write the coefficient of z variable, that numbers are 3, 4 and 4. Next is a variable matrix, that is x, y, z equal to the right hand side value, that is constant value which is given to us in the equation, that is 12, 15 and 13. Now this is our diagonal element 1, 4 and 4. We have to make first below this diagonal all entries are 0 with respect to the diagonal element. Now, which row operation should we have to perform? We have to make second row and third row at this position 0. So, these numbers are 1. So, R2 minus R1, it becomes 0. Same way in the third row, it is also 1. So, R3 minus R1, it becomes 0. So, this two row operation now we are going to perform, and same row operation we are going to perform on right hand side also. So first row as it is, so 1, 3, 3, x and 12. For second row, R2 minus R1, that is 1 minus 1, entry becomes 0. Next element is 4 minus 3, it becomes 1. Next second element is 4 minus 3, again it is 1. Variable matrix as it is, right hand side value, R2 minus R1, 15 minus 12, it becomes 3. Now let's move to the third row, R3. R3 minus R1, again 1 minus 1, 0, 3 minus 3, 0, 4 minus 3, diagonal value become 1. Equal to right hand side value constant 13 minus 12, it becomes 1. Now it reduced to an upper triangular matrix. अगर आप चाहते हो थर्ड स्टेप को फॉलो करना, यहीं पे कोएफिशिएंट मैट्रिक्स अपर ट्रायंगुलर को कन्वर्ट हो चुका है. यू कैन राइट हियर 1x plus 3y plus 3z equal to 12, 1x plus 1y equal to 3 and 1z is equal to 1. यहाँ पे आपको z की वैल्यू मिल जाएगी, y की वैल्यू मिल जाएगी. Substitute in that equation. In this way also we can solve it. But अभी हमने देखा कि हमें ये डायगोनल मैट्रिक्स को कन्वर्ट करना है. एक तो आप यहाँ पे सॉल्व करके इलिमिनेशन मेथड से एक्स वाई जेड फाइंड आउट करो, अदरवाइज मूव फर्दर टू रिड्यूस द coefficient matrix to the diagonal matrix. Now this is a upper triangular matrix. Now apply R1 minus 3 times R2. अभी ये रो ऑपरेशन हमने क्यों परफॉर्म किया यहाँ पे? क्योंकि हमें फर्स्ट रो में 0 लाना है. So same matrix will be carry forward here 1 3 3. For this position now we have to bring here 0. So R1 minus 3 times R2 and second R2 minus R3. So what we get? This element, that means we get after simplification the diagonal matrix. So these are x, y, z variable matrix equal to the same row transformation we are apply on the right hand side, that is constant matrix. So we get 3 2 1. Now rewriting the equation, 1x is equal to 3, 1y equal to 2 and 1z is equal to 1. So in this way we get the required solution as x, y, z equal to 3, 2 and 1. So this about the second example. Now let's take the word problem. Read it carefully. Third problem, if three numbers are added, their sum is 2. Okay, three numbers are there but we don't know what are that number. So let first suppose that number be x, y and z. So this is about our first statement. Let's read the sentence first. If 2 times the second number is subtracted from the sum of first and third number, we get 8. And if the 3 times the first number is added to the sum of second and third number, we get 4. find the number by using matrices. So first जो कोई भी word problem हमें दिया है we have to convert it into the system of linear equation. अभी ये आपने ध्यान से पढ़ा होगा तो आपको समझ में आया होगा यहाँ पे कितने numbers हमें find out करने हैं. We have to find out 3 numbers but हमें पता नहीं है what are that numbers. So let us suppose that first number be x, second number be y and the third number be z. तो एक्स वाई जेड हमने सपोज कर लिया और हमें एक्स वाई जेड की वैल्यू फाइंड आउट करनी है. अभी फर्स्ट स्टेटमेंट वापस से रीड करते हैं. द 3 नंबर्स आर एडेड. इसका मतलब क्या हुआ कि एक्स वाई और जेड को अगर हमने ऐड किया देन दियर सम इज 2. तो उसकी सम हमें मिलती है 2. दैट इज आवर फर्स्ट इक्वेशन. सो राइट हियर x प्लस वाई प्लस जेड इज इक्वल टू 2. अभी नेक्स्ट सेंटेंस रीड करो. इफ 2 टाइम्स द सेकेंड नंबर, व्हाट इज आवर सेकेंड नंबर? Our second number is y. It is 2 times. So write here 2 times y which is subtracted, इसलिए minus किया from what? From the sum of first and third number. First and third number है हमारा x and z. इनके sum में से हमें subtract करना है. So मैंने क्या किया यहाँ पे x plus z की addition की minus 2 times y. तो हमें कौन सा number मिलता है? We get 8 number. So which is equal to 8. Now this is our second equation. Now next statement is what is that? 3 times the first number. What is our first number? First number is x but it is 3 times. So write here 3x plus the number is added to the sum of second and third number. अभी 3 times x कहाँ पे add करना है? Second and third number के addition में. So 3x plus y plus z equal to what we get? That number is 4. So from the given word problems we can convert it into the system of linear equation first and then follow the steps which is we have already solved the problems. Now this is our system of linear equation. Convert it into the matrix equation. Now we know the matrix equation is Ax is equal to B. A is a coefficient matrix. So write in the first column coefficient of x variable, in the second column coefficient of y variable and in the third column coefficient of z variable. हमें कोएफिशिएंट मैट्रिक्स किसको रिड्यूस करना है? या तो अपर ट्रायंगुलर को रिड्यूस करो, लोअर ट्रायंगुलर मैट्रिक्स को या फिर डायगोनल मैट्रिक्स. चॉइस इज योर. सो लेट्स reduce the coefficient matrix to the upper triangular matrix और जो ट्रांसफॉर्मेशन जो रो ऑपरेशन हम coefficient matrix को लगाएंगे same row operation we are going to perform on right hand side. So this is our diagonal element 1 minus 2 and 1. अभी हमें ये डायगोनल के नीचे के सारे एलिमेंट जीरो करने हैं. सो यहाँ पे जीरो लाने के लिए सेकेंड रो विल बी चेंज. R2 माइनस R1 ऑपरेशन कर दो, दिस नंबर बिकम जीरो. यहाँ पे जीरो करने के लिए थर्ड रो R3 माइनस 3 टाइम्स R1. सो आफ्टर परफॉर्मिंग दिस टू रो ऑपरेशन व्हाट वी गेट आफ्टर सिंप्लीफिकेशन ऑफ दिस, फर्स्ट रो विल बी नो चेंज 1 1 1 x and 2. Second row and third row element we get 0 minus 3 0 0 minus 2 minus 2 and right hand side value we get 6 minus 2. Now only one element remain, that number is A3 2. We have to make it 0 with respect to this second diagonal element. That second diagonal element is minus 3. So this number is minus 3. First reduce that number to 1. How it will be 1? By multiplying minus 1 by 3. So second row will be changed first. Multiply second row with minus 1 by 3. So minus minus become plus. 3 get cancelled. We get the value 1. The same element will be multiplied by that number. यहाँ पे 0 0 ही आएगा. Already 0 ही value है. So 0 into anything we get 0. Right hand side पे परफॉर्म करते हैं. Second R2 row is 6 into minus 1 by 3. So after simplification we get minus 2. So first row and third row will be as it is. Now we have to make this position A32 equal to 0. It occurs in the third row. Third row will be changed now. How it will be changed? R3 plus 2 times R2. So what we get after performing this operation? We get the third row as 0 0 minus 2 and right hand side value minus 6. We have to apply the same row operation on constant matrix also, that is B matrix. First and second row as it is. So now this matrix, coefficient matrix becomes an upper triangular matrix. Now observe this below this all diagonal element, all the entries are 0, so it becomes a upper triangular matrix. Now reduce it to the linear equation. 1x plus 1y plus 1z is equal to 2. This is our first equation. Now second equation, 0 into x, no need to write. 1 into y, so only y. 0 into z, so z again no need to write. So what we get, y is equal to minus 2. This is our second equation. And in the third equation, 0 into x plus 0 into y plus minus 2 into z. So minus 2 into z is equal to right hand side value minus 6. From second and third we get the value of y and z. So after simplification of third equation, z is equal to what we get? Z is equal to 3. Substitute this value in the first equation. We have the value of y is equal to minus 2. Y is equal to minus 2 and z is equal to 3 in the equation first. We get the value of x is equal to 1. So this is our required solution. I hope you understand. The value of x is 1, y is minus 2 and z is 3. So this is about the reduction method. थैंक यू स्टूडेंट्स. अगर आपको मेरा वीडियो अच्छा लगा है तो शेयर करना, लाइक करना और सब्सक्राइब करना मत भूलिए. थैंक यू.